Okay, so this is day 2 of solving absolute value inequalities. So remember, we have our steps as you must isolate the absolute value first. Then step 2, so remember you can only check for special cases after it's isolated. And remember there are special cases when you have a absolute value with a negative, because you can't have a negative distance. And again, there's really more special cases with absolute value inequalities, but we're not going to go over the zero type cases. Those take a little bit more time, and so we're going to leave those maybe for algebra 2. So there are a few other ones. We're just going to cover the negative ones. And then if there are no special cases, then you're going to write the correct compound sentence. So you have to make sure you write the correct one. And then, of course, the last thing is to solve. So let's go over why we write a compound sentence. So in number 1, again, we're talking about all the numbers that are less than, right, that are less than or equal to 6. So that means, what are the numbers on the number line that are less than 6 units away from 0? Right? Less than 6 units. If you're standing at 7, you are more than 6 units. If you're standing at 8, you are more than 6 units. So you have to be less than. So you have to be less than 6 units from 0. So that means you have to be standing at 5 and 4 and 3 and 2 and 1, etc. Or, 5.9999999 or 4.3 or 4.25. And you can also be standing at negative 5.9999999 or negative 5 or negative 4 or negative 3 or negative 2. You can even be standing on 6. So basically you have to be standing in between. And the reason why you can be standing on 6 is because there's an equal to symbol. But as you can see, we have a compound and. Remember last week we were doing compound ors and compound ands, and you can see we have a compound and situation. It's a between situation. And we should feel pretty comfortable with how to write a between statement. There are technically 2 ways to write it, but I would prefer you guys write it as in using the between style. And it's always going to end up being less than symbols, less than symbols. So you technically could write it all the numbers that are greater than or to the right of negative 6, and then you'd have to use the word and if you're going to write it this other way, and then all the numbers to the left are all the numbers that are less than or equal to positive 6. So these both mean the same thing, but we would prefer that you write the between type statement. So on example number 2, notice that we are looking at the absolute value is greater than or equal to. So that means you have to be more than 2 units from 0. More than 2 units. So if you're standing at 1, you're not more than 2 units. So you have to be standing at, 3 and 4 and 5 and 6, or negative 3, negative 4, negative 5, negative 6. And because of the equal to symbol, it's going to be solid. So you have to be standing on the outside of 2 and on the outside of negative 2. And if you remember from last week, we go, wait a minute, isn't this a compound or type picture? And then how do we write a compound or? Well, we have to write a sentence that is going to the left of negative 2, and we have to write a sentence that is going to the right of positive 2. So we're going to say all the numbers that are less than or equal to negative 2, right? Because to the left is less than, and to the right is greater than. And then you have to have the word or in there. All the numbers that are greater than or equal to positive 2. And remember, because the original problem was an equal to symbol, so these should be solid. And then we should have an equal to symbol in our compound sentence. Okay, so let's look at number 3. So remember, the step 1 is to isolate the absolute value. So anything that is outside of the absolute value. And notice we have a divide by 2 in the denominator and the absolute values in the numerator. So we have to undo that dividing by 2. So we're going to undo dividing by 2. Remember, to undo division, we multiply. So we're going to multiply by 2. Notice how I tried to make the multiplication sign in the same spot as the division and tried to make it as big as the fraction. And that leaves us the absolute value of x plus 4 is greater than 12. And this is officially step 1 is done now. Remember, step 1 is to isolate. Check step 1 is done. Right, so I just want to emphasize, you have to have that step 1 on your paper. It's a critical step. So we're going to be looking for that critical step. And then step 2 is to check to see if it's a no solution situation. So we're looking to see if there happens to be a negative here. And there is no negative because you can't have negative distance. So the fact that there is no negative, step 2 does not apply. But we want to make sure that you're looking for that you don't just get in the habit of going right to step 3. Step 3 is to write the correct compound sentence. So if we're saying you must be more, right? This is a greater than symbol, which says you must be more than 12 units from 0. Where would you have to be standing? Would you be standing in between 12 and negative 12? Or would you be standing on the outside of 12 and negative 12? If you have to be more than 12 units from 0. So again, I don't have any space. I would maybe do this off to the side of my paper. Let's see if I can move this down a little bit. So maybe off to the side of my paper, I might be thinking, right, what does this mean? So if I'm at negative 12 and positive 12, and I have to be more than, wouldn't I have to be on the outside of positive 12 and on the outside of negative 12? And it would be open circle since there's no equal to symbol underneath there. So isn't that a compound or? So I have to write a compound or statement. So I have to write a sentence that goes to the left of negative 12. Remember, to the left is less than. And I have to write another sentence. Sentence number 2 has to be written to the right or greater than positive 12. And so I'm going to write this one first. So I'm going to write x plus 4 has to be to the left or less than negative 12, or x plus 4 has to be to the right or greater than positive 12. And let's erase this a little bit. Getting in the way. So hopefully you understand like why we're writing the compound sentences. We're trying to emulate this picture. And this picture has 2 inequality statements. One going to the left and one going to the right. So one going to the left of negative 12 and one going to the right of positive 12. So now that we wrote the correct compound sentence, which is step 3, is to write the correct compound sentence. And then step 4 is to solve that compound. Your or has to come down. That is part of your answer. You can't leave that out. Super critical. You can't just start dropping symbols and words, right? So this is your final answer. And then if you wanted to graph it, even though it technically didn't say to graph it, we need all the numbers that are less than negative 12 and all the numbers that are greater than 8. And so again, kids will say, well, what was this other graph for? Well, again, this other graph was only there to help us decide whether we should write a compound or an and. So you might have noticed, you might have said, well, I'm starting to notice a pattern here. I'm starting to notice that whenever it is a greater than symbol, it seems that I have to write a compound or because it's a greater than symbol. And if you notice that pattern, that is correct. And so you have to write all the numbers that are less than negative 12 because you're going to the left of negative 12 because you have to be more than 12 units. So negative 13, negative 14, negative 15, or to the right of positive 12, like 13, 14, 15, 16, because again, you have to be more than 12 units from 0. So that means you have to be to the left of negative 12, or you can be to the right of positive 12. So yes, if you see an absolute value is greater, that means you must write a compound or. So if you started to figure out that pattern, good for you, right? Good job on that. Okay, let's look at the next one. So again, we must, step 1 is to isolate anything that's outside of the absolute value. So we have a negative 7 that we have to undo because it is outside the absolute value. So we're going to undo a negative 7 by adding positive 7. Because isn't that just 0? And isn't 0 plus anything just exactly that same thing back? And that is 15. So we're looking for that step 1. You have to write that step 1. We're looking that is on your paper. It can't just be in your head. And then step 2 is to look and see if there's a negative, because that would be a special case. And we'd have to analyze if it was no solution or if it was all real numbers, but it's not a negative distance. So we can go to step 3, which is to write the correct compound sentence. So this time we have to be less than 15 units away. So if it's less than or equal to or less than, so you have to be less than 15 units away from 0. Would you be standing between 15 and negative 15? So where would you be standing if it was less than 15 units from 0? Think about that for a minute. Would you be standing in between negative 15 and 15 or on the outside? And less than 15 units, wouldn't that be like 14 and 13 and 12, etc.? So you'd be standing in between, right? You'd have to stand in between, and because of the equal to symbol, that would be closed. So therefore, we have to write a compound and. So if you're saying, I notice every single time it's a less than symbol, we seem to have a between situation. Is that always going to be true? Yes, that will always be true. Once you've isolated, if it is a less than, wouldn't that mean you have to be in between negative 15 and 15? So 2n minus 3 has to be between positive 15 and negative 15. So hopefully you're picking up on, right? It has to be between negative 15 and positive 15. And I forgot my equal to symbol there. And then we have to solve this compound sentence. So remember, we have to undo the subtract 3, then we'll undo the multiplying. We always undo subtraction first and undo adding and multiplying second. So we have to add 3. We have to add 3 to both ends. Remember, many of you are forgetting to add 3 on this end as well. Remember, we are solving 2 inequalities simultaneously, right? It's a shortcut. And that gives us negative 12. We don't want you to break it apart. We want you to learn how to do it without breaking it apart. I know that on other YouTube videos or photo math, they show you breaking it apart and then solving the two separately, but that's a waste of time, and we want you guys to learn how to solve it the simultaneously between way. And then we got to undo multiplication, so we have to divide. And if we wanted to graph that would be all the numbers that are has to be right equal to, has to be a closed circle, shaded circle. So here are all the solutions. So this would have been your answer. Remember, you can always stop this video and go back and try these problems on your own before you even watch me do them. So you could have tried to do a problem first before you even watched me do it. Okay, here's another problem, number 5. Once again, we need to isolate step 1. So start practicing memorizing your steps. And what do each of the steps mean? Like isolate, I don't know. What does that mean? So it means to undo anything that is outside of an absolute value. Don't undo anything inside, only operations that are outside. And remember, that means multiplication. So we have to undo multiply by dividing by negative 2. And that's going to give me the absolute value of x plus 6 is, oh, didn't I divide by a negative? And isn't there a rule, a reverse rule? It says if you ever multiply or divide by a negative, you have to reverse the inequality. So step 1 is officially done. So don't forget about that reverse rule. So step 1 is isolated. Step 2 is to check to see if we have a special case, and we do have a special case. We have a negative distance. So we're going to use what's called sign analysis to decide. We know it's got to be either all real numbers or no solution, but we have to figure out which one it is, and we don't want to just guess. So let's use some common sense. So the absolute value is always got to be positive. So no matter what you put in the absolute value, this is always going to come out to be positive. But yet this side to the right is negative. Is that always true? Is a positive smaller than a negative? Isn't that never true? That is never going to happen. A positive number is never less than, and a positive number is never equal to. So therefore, that is no solution. And if you want to write NS, that's fine. So you cannot have an absolute value And if you want to memorize, you can memorize it when it's less than and you have a negative, it's no solution. But we really don't want you to memorize because that's only going to last for a couple days. As soon as you start doing something else, you're going to go, wait, I can't remember that. We want you to use some common sense. And the idea that absolute value is always going to come out positive because we're talking about distance has to always be positive. And then you're just using what we call sign analysis. And a positive is never less than true. So let's look at number 6. So which ones are real numbers? So let's use sign analysis. So remember, before you can decide if it's an all real numbers or a no solution, step 1, isolate the absolute value, has to be done. So notice on letter A, step 1 is done. Check. So step 2, we do have a negative special case. We can't have a negative distance. So we're going to do sign analysis. Absolute value is always going to come out. So this is side, the left side is always going to be positive, and the right hand side has a negative. Is a positive number always bigger than a negative number? Is it never true? Sometimes true? So isn't that always going to be true? Therefore, this is all real numbers, right? Because that is always going to be true. So therefore, your final answer should be all real numbers. So this one would be all real numbers. Let's look at B. Notice that step 1 is already done. It's already isolated. Step 1, done. It's already isolated. We see that we have a negative number, so we know we have a special case. And let's do sign analysis. We have this absolute value is always going to come out to be a positive. And we have a positive is less than a negative. Is that true? Is a positive really less than a negative? That is not true. That is false. So this is no solution. That's never going to be true. So this one, it says which ones are going to be all real numbers. This one's not an all real numbers. It's actually a no solution. Letter C. Remember, we cannot analyze. We first have to undo and get it into step 1 first before we check for step 2, special cases. And now that step 1 is officially done, we do see that we do have a special case. So we're going to do sign analysis. A positive number, is that greater than a negative number? And that is always true. So your answer is not true. Remember, on a test, you can't say it's true. Your final answer is all real numbers. That means no matter what number you pick on the number line, any number, 2/3, square root of 5, pi, 7, 2/7, 0, -3, -8, it's always going to make this sentence true no matter what. Right? So any number you pick is going to make that original sentence true. Those are called solutions. Letter D. In order to determine whether we have a special case, we must have the absolute value isolated. And isolate means to undo anything that's outside the absolute value. Now, some students will add 4 to both sides, and that's not correct. Be careful. Don't fall for that. You're not subtracting 4 to the absolute value. You are multiplying. Remember, that means multiply. So you don't undo multiplication with adding 4. You undo multiplication with dividing by a -4. So be careful. Everybody always puts add 4 right there because they forget that means multiplication. And didn't I just divide by a negative number? So don't we have the reverse rule that says if you divide by a negative number, don't we have to reverse this to a greater than? And isn't that -3? So now step 1 is done. And we see that we do have a negative distance. So we need to do sign analysis, and absolute value is always going to be positive. And is a positive greater than or equal to a negative? Isn't a positive always going to be greater than a negative? So isn't this all real numbers? So again, this isn't your answer. Your answer is either all real numbers or no solution. Writing your answer as positive greater than negative is true is not your answer. Your answer is either all real numbers or no solution. So this one is in all real numbers. This one's in all real numbers. This one's in all real numbers, right? So far we have A, B, A, C, whoops, A, C, and D so far are all real numbers, right? Because it said which ones are all real numbers. And then let's see about E. Don't we have to undo subtracting 10? So now step 1 is done. So notice that this isn't even a special case at all, right? There's no negative number, so this isn't even a special case at all. So this is actually going to have an answer. And wouldn't we have to write a compound? Which one would we write? Would we write a compound or a compound and? If it is more than 8 units from 0, would you have to be standing on the outside of 8 and negative 8, or would you have to be standing in between 8 and negative 8 if you're more than 8 units? So if you said you had to write a compound or, you would be correct. So there you'd have to write an or. So that would be x plus 6 is to the left of negative 8, or x plus 6 would have to be to the right of positive 8. And we're not going to solve that because they didn't really ask us to solve that. I just wanted to kind of walk you through part of that because the question was really just which of these are all real number type situations. Okay, and let's look at number 6 and we'll stop there. Number 6, once again, we need to undo everything that's outside. Everything that's outside. So we have 2 undos to do. We always undo adding and subtracting first, and then we'll undo the multiplication second. So we need to add 7. Then we can multiply by 3. You could divide by 3 if you wanted to, but it's just much easier to multiply by the reciprocal. And then now that step 1 is officially done, right? So step 1, check, is done. Step 2 is to see if it's a negative special case, which it's not a negative special case. And then step 3 is to write the correct compound sentence. If you have to be less than 33 units from 0, where would you be standing? So if you're less than 33 units from 0, would you be standing in between 33 and negative 33? Or would you be standing on the outside of 33 and negative 33? If it helps you, right? If it helps you to draw a little just thinking box and just kind of think out what that would mean. So you got negative 13 and 0, and you have to be less than 33 units from 0. Don't you have to be in between? So therefore, don't we have to write an and? So we're going to write a compound between statement. So we have to be between negative 13 and positive, negative 33 and positive 33. Right? And then we have to undo subtracting 2 by adding 2. Don't forget you have to do it to both ends because why? Because we're solving 2 inequalities simultaneously. So isn't that negative 31 is less than x is less than 35? And if we wanted to, we could graph it, and we want all the numbers that are between 35 and negative 31. So that's your answers. Okay, so I hope you're getting better at solving absolute value inequalities. Have a good day.